Mars, a world we once thought lifeless, dry and still. But in 2021, China's Zhurong rover pierced beneath its crimson plains and uncovered something extraordinary. 30 feet below the dust, radar revealed tilted layers stacked like waves frozen in stone. A buried shoreline, a whisper of an ocean that may have once stretched farther than the Arctic, lingering not for days or years but millions of years. If Mars truly held seas that long, then it may also have held life, and perhaps traces of that life are still waiting in the soil. This is not just science, it is the spark of a new space race. Nations now scramble to bring Martian samples back to Earth, knowing that inside a single grain of red sand could lie the most important discovery in human history. What Zhurong uncovered is more than geology. It is a doorway into a mystery older than our own oceans, and a reminder that Mars may yet hold answers we are not ready to hear. Prepare for a journey through oceans lost, secrets buried, and a race that could decide who discovers life first. We begin. The Martian desert is a silence that weighs upon the mind. It is not the silence of an empty room or a midnight forest, but the silence of a planet that has not known the sound of rain in billions of years. Across Utopia Planitia, a vast plain so wide that it dwarfs entire continents of Earth, the wind carries fine red dust. Grains so small they would vanish between your fingertips swirl endlessly, lifted and dropped by an atmosphere barely clinging to existence. It is here, in this ocean of stone, that China's rover Zhurong began to uncover a shoreline no human eyes had ever seen. Imagine walking across a desert and feeling beneath your boots the faint crunch of buried shells, knowing the ocean once lapped where dunes now rise. Mars offers a similar paradox, a desert that remembers tides, but the memory is hidden and only machines can listen to its echoes. Zhurong, with its ground-penetrating radar, was sent to peel back the skin of the planet, to look beneath the dust where geology keeps its secrets. What it found was a buried structure 33 feet below the surface, a layer of sediment tilted at an angle, stretching mile after mile like a frozen whisper of a vanished sea. This was no ordinary deposit. On Earth, wedges of sand and gravel that tilt gently in one direction often mark the work of waves. Sediments pushed forward, grain by grain, as shorelines advance. To a geologist, the sight is unmistakable, the patient hand of water at work. But on Mars, where rivers are long dry and seas are myths from the past, such a discovery shakes our assumptions. For decades, scientists debated whether Mars ever truly held oceans, or whether its surface was carved by brief floods, violent and temporary. Here, the radar readings seem to offer something more enduring. A shoreline preserved, a coast where water lingered, not for days but perhaps for millions of years. The layers were thick. In places, over 100 feet of deposits lay stacked like the chapters of a drowned history. Such thickness suggests persistence. On Earth, it takes vast spans of time for sediment to accumulate so deeply. If Mars once allowed this, it was not a fleeting flood but a standing body, an ocean with waves, currents and a rhythm of seasons. Utopia Planitia, the landing site, may have been a basin filled with water larger than the Mediterranean, as some models suggest. And Zhurong's findings did not contradict those dreams, they breathed life into them. Yet, as with all things Martian, certainty slips away like dust in the wind. Not all scientists agree the radar data proves an ancient ocean. Some argue the tilted layers could be the remains of volcanic flows, shaped not by water but by fire. Others see the work of wind, piling dunes that later solidified under the planet's thin breath. The debate is fierce, because Mars holds too few clues and too many interpretations. Every layer uncovered by radar is a riddle written in stone, and our machines can only read fragments. Still, the imagery lingers. Picture standing at the edge of that ancient coast, a pink sky above you, thin sunlight filtering through the dust. The air would taste metallic, thin enough to burn your lungs if you dared breathe it. Yet before you, stretching to the horizon, might have been a sea of brackish water, rippling under winds that no longer blow. The waves could have crashed gently against basalt cliffs, scattering spray that froze before it fell. Here, the possibility of life once trembled. Microbes could have drifted in the currents, clinging to minerals, hiding in sheltered pools. The chemistry of Mars, rich in iron and carbonates, would have offered a banquet for simple cells had they existed. But the shoreline Zhurong traced was not simply a scientific curiosity, it was a story of time. To preserve such layers, Mars had to be warm enough, stable enough, wet enough to keep an ocean alive for ages. That means the planet once possessed a thicker atmosphere, dense enough to hold heat, heavy enough to let rain fall. To imagine this is to glimpse a world far different from the barren one we know, clouds drifting in a deeper sky, rivers running toward an inland sea, perhaps even storms rolling in thunder across Martian plains. What today is a graveyard of dust was once alive with water, movement and sound. Of course, the rover itself could not hear such echoes. Its wheels pressed gently into the soil, tracing just over a mile of terrain before silence claimed it. Yet in that distance, the machine carried a story across the ages. Radar pulses sent beneath the crust bounced back with faint signals, each reflection a memory of how matter once settled. 33 feet down, the echoes grew stronger, revealing tilted beds like the pages of a buried book. Deeper still, at over 100 feet, the layering continued, thick and patient. In this data, geologists saw the song of a sea, a rhythm preserved in mineral and dust. But speculation does not end with oceans. Some fringe thinkers wonder if these deposits, if truly beaches, could hide fossils unlike any on Earth. Not the bones of animals. Mars never offered enough time or energy for such grandeur, but the microscopic remains of cells. If preserved, they would be locked in the very sediments now revealed by radar. To hold in our hands a grain of Martian sand bearing the imprint of life would be to rewrite our place in the cosmos. Whether such remains exist, no one yet knows. The layers may be mute, their secrets eroded by time, or they may whisper truths we have not yet learned to hear. The shoreline of Mars is more than geology. It is a mirror. It reflects the fragility of oceans, the ease with which water can vanish, the thin line between life and silence. Earth's own seas seem eternal, but Mars teaches otherwise. Worlds can dry, rivers can die, and coastlines can fade into memory. What Zhurong uncovered was not just a scientific fact, but a warning carved in alien stone. And so we drift with the rover's last echoes, deeper into the mystery. The dust hides more than waves. It hides the story of a mission itself, of a fleet sent across the void, daring to land where failure had swallowed so many before. To understand the shoreline, we must understand the journey that carried a machine from Earth's skies to Mars's silence. The discovery of the buried beach is only the beginning. The dream of a buried shoreline could not exist without the daring machine that made landfall on another world. Before radar pierced the Martian crust, before wheels rolled across the red plain, there was a launch from Earth, a leap of fire and mathematics that carried a nation's first steps toward Mars. The mission bore a name written in poetry, Tianwen, meaning questions to heaven. And in that name is the heart of the story, for Mars is a heaven that answers only in riddles. July 23rd, 2020. From the Wenchang space launch site on Hainan Island, a Long March 5 rocket rose through the humid summer air, carrying within its fairing a complex trio of spacecraft, orbiter, lander, and rover. Other nations had attempted this piece by piece, but China attempted it all at once, an entire fleet wrapped into a single mission. It was a gamble of breathtaking ambition, one that spoke not only of science but of symbolism. To land a rover is to place a flag in silence, to carve presence into alien soil. The journey was long, nearly 7 months through the emptiness between worlds. During that time, Tianwen-1 coasted quietly, adjusting its trajectory, its instruments sleeping and waking like organs in a patient state of meditation. The distance travelled was immense, hundreds of millions of kilometers, yet guided by equations so precise that the spacecraft arrived within minutes of its planned encounter. February 2021 brought the moment of truth, orbital insertion. With engines roaring in the vacuum, Tianwen-1 bled speed and was captured by the gravity of Mars, settling into a long elliptical path that gave it a view of the entire planet. From orbit, Mars revealed itself not as a red dot, but as a living map of canyons, craters, and plains. The orbiter's cameras gazed down upon Valles Marineris, a canyon system that could swallow continents, and upon Olympus Mons, a volcano 3 times taller than Everest. but its greatest focus lay on Utopia Planitia, a broad basin suspected to be the resting place of an ancient sea. There, in the spring of 2021, the lander was released, wrapped in a cocoon of heat shield and parachute. It plunged into thin air. The descent was both brutal and fragile, a capsule carving through an atmosphere barely strong enough to slow it, retro rockets firing in a final ballet, and then silence as metal legs pressed into alien soil. On May 14, 2021, the rover Zhurong touched the surface. It was the first time China had landed on Mars, and with that moment it became only the second nation in history to operate a rover there. For weeks, engineers back on Earth waited anxiously, as dust storms could have swallowed the signal, or the lander could have collapsed under the planet's unforgiving cold. But the rover awoke, unfurled its solar panels like wings, and rolled gently down its ramp onto the plain. Its wheels pressed into dust that had not been touched in billions of years. Zhurong carried 6 instruments, each a window into Mars's hidden self. Cameras to map the horizon, spectrometers to taste the minerals, and radar to peer beneath the ground. It was a modest rover by comparison to NASA's towering Perseverance, but it carried ambition far larger than its size. Its mission was to wander across Utopia Planitia, gather clues of water, and whisper back to Earth the story written in Martian soil. As the days passed, the rover travelled more than a mile across the plain. Each meter was deliberate, each pause a chance to study the texture of rocks, the layering of sand, the faint glimmer of minerals that once formed in water. The orbiter high above relayed signals, bridging the distance between two worlds. Data streamed across space, arriving seconds late, a reminder of the vast gap that even light must cross. Yet, what made Tianwen-1 extraordinary was not only its technical success, but the symbolism behind it. For China, the mission was more than science. It was a declaration of presence in the cosmic arena. The history of space had long been a contest of nations, from the Apollo landings to the robotic explorers of the American West. By landing Zhurong, China carved its place in this lineage. The rover's tracks in Martian dust were as much political as geological. They told the universe we too can explore beyond Earth. Still, there is fragility in triumph. The rover's design depended on solar panels, and the dust of Mars is a patient killer. Grains lifted by storms settle upon panels, dimming their light, stealing energy. As months passed, dust grew heavier, storms more frequent, and temperatures colder. The silence of Utopia Planitia deepened, and one day in May 2022, the rover failed to wake. Engineers sent signals, waited for replies, but the red world gave nothing back. Perhaps the panels are covered, perhaps the cold has frozen its circuits, perhaps it sleeps forever. Yet even in silence, the mission speaks. The data it returned, the radar slices of subsurface layers, the images of tilted strata, the whispers of a buried shoreline, these remain. From orbit, Tianwen-1 still circles the planet, its instruments alive, its cameras sending down views of Martian weather. But the rover is now a monument, a machine standing on a foreign shore, silent yet triumphant. The scientific legacy of this mission is profound. For decades, debates raged about the presence of oceans on Mars. Viking orbiters in the 1970s photographed channels that hinted at floods. Later missions detected minerals formed in water, but evidence of a true sea remained elusive. Zhurong's radar added a new voice to this chorus, tilted wedges of sediment, deposits as thick as city blocks, layered deep beneath dust. Was this proof of a shoreline or an illusion of geology? The debate continues, but the mission ignited new fire in the question. And so, we find ourselves standing at a threshold. One rover, one lander, one orbiter. And suddenly, the question of Martian oceans feels less like myth and more like memory. Yet memory must be tested. To prove beyond doubt, we need samples returned to Earth. Rocks that can be cut and studied under microscopes. Sediments that can reveal whether they once cradled life. Tianwen-1's greatest contribution may not be the discovery itself, but the doorway it opened for what comes next. For beyond the buried shoreline lies the story of oceans without waves, seas that vanished into dust, and a planet that once might have been alive. To walk that path, we must follow the rover's faint tracks deeper into the Martian heart, where science and speculation blur like the horizon in a dust storm. The plane called Utopia Planitia stretches so far that even from orbit it looks endless. A scarlet expanse where horizon and sky bleed together in muted tones of rust. It is here, upon this vast Martian basin, that the small rover Zhurong left its faint mark. Imagine the scale, a world-sized desert, and upon it, a machine no taller than a person, rolling forward on 6 wheels the width of your hand. In the silence of a planet where no footsteps exist, those shallow tracks became the first lines of a new story. The rover's journey began cautiously. After sliding down its ramp from the lander, it paused, as if listening to the alien world around it. The cameras on its mast turned slowly, capturing a panorama of stone and dust, a flat plain, broken only by scattered boulders and the rippling ridges of ancient dunes. To human eyes, the landscape would feel desolate, but to scientists, every grain of sand was a record of the planet's past. Zhurong advanced with patience. In total, it would cover about 1.2 miles across Utopia Planitia, a distance laughably small on Earth, where a human can stroll that far in less than half an hour. But on Mars, each meter was a negotiation between risk and reward. Every wheel rotation had to be commanded from Earth, every obstacle assessed with care. If a wheel sank into soft sand, there was no rescue. If dust coated its panels too heavily, power would fade. And yet, step by step, the rover pressed forward. Along the way, its cameras revealed textures in the soil, small ripples shaped by wind, their curves frozen into place. Rocks showed surfaces smoothed as though water once flowed around them. Some were fractured, their interiors gleaming with minerals that only form in liquid. The rover's spectrometers confirmed what the eyes suspected, the chemical fingerprints of interaction with water long ago. This was no sterile desert sculpted only by wind. It was the dried bed of a world that once breathed moisture. But the most haunting contribution came not from its cameras but from its radar. Each time Zhurong moved, it carried beneath it a probing signal, a pulse that dove downward into the crust. The echoes returned like whispers through stone. At first, they showed simple layering near the surface, sheets of dust, compacted sand, debris left by storms. But deeper still, at 30 feet, the radar revealed structures aligned at angles, tilted as though a shoreline had once advanced and retreated with the tides. These were the very patterns geologists call prograding wedges, familiar on Earth at ancient beaches and deltas. Walking in the rover's tracks would have felt strange to us. The soil, so fine and powdery, would compress underfoot with barely a sound. Each step would leave a sharp imprint, untouched by wind for perhaps centuries, as Mars's thin atmosphere lacks the force to quickly erase them. Looking back, you would see the line of your passage stretching endlessly into the horizon, just as the rover's wheels carved scars into dust that had lain undisturbed for billions of years. The journey across Utopia Planitia was not only physical, it was symbolic. For centuries, the plane has fascinated astronomers. Viking 2, an American lander, touched down in this same region in 1976, conducting experiments that hinted at but did not prove the presence of life. To return to this place 45 years later with a more advanced machine was to reopen an unfinished question. What Viking began, Zhurong continued. But where Viking's instruments dug just inches into soil, Zhurong reached deep. Its radar sliced through more than 100 feet of crust, pulling forth a story of deposition and change. Scientists debated fiercely. Was this truly a shoreline, or could volcanic flows or dune fields explain the patterns? The rover's data could not answer alone, yet its wheels gave humanity something vital, a reason to ask the question again with renewed urgency. As Zhurong pressed forward, storms gathered on the horizon. Mars is a planet of dust. Storms can rise without warning, expanding until they cover entire hemispheres. The rover's cameras occasionally captured skies thick with haze, the sun dimmed to a pale disk. For a machine dependent on solar panels, such weather was perilous. Engineers watched nervously from Earth, calculating power levels, timing transmissions. Still, Zhurong endured, creeping onward in its deliberate quest. At each stop, it turned its instruments to rocks like a curious child. Some boulders bore the marks of impact, shattered by ancient collisions with meteorites. Others showed layering that suggested water or wind had shaped them. In one outcrop, the Rover spectrometer found hydrated minerals, formed only when water weaves into crystal structure. These discoveries tied the landscape not to emptiness, but to memory, a memory of a wetter world. Walking beside it in imagination, you would notice how alien the light feels. The sun is farther from Mars than from Earth, and the air is thinner, scattering less blue. The sky glows a dusty orange, and shadows stretch crisp and dark across the plain. The silence is total. No birds, no insects, no breeze strong enough to sing. Only the soft crunch of wheels in soil, carrying a lonely ambassador of humanity into mystery. Yet even loneliness has meaning. The rover's path across Utopia Planitia marked more than science. It was a quiet statement of presence. Where once only Vikings stood, now Zhurong had come. It showed that exploration is no longer the dream of one nation, but of many, each adding its voice to the cosmic dialogue. Its tracks in dust are a signature written across time. But with each day, the burden of survival grew heavier. Dust crept over its solar panels, dimming the light. Nights plunged temperatures to -100 degrees Celsius, threatening its circuits. Engineers instructed it to rest during storms, conserving energy, waiting for skies to clear. For a year, it endured. Then, in May 2022, it ceased communication. Perhaps it sleeps, awaiting sunlight to awaken its frozen heart. Perhaps it has spoken its last. Either way, its journey remains etched in the soil, a line of wheels across a plain that once may have been a seabed. The rover's wanderings gave us not only images and data, but perspective. We are creatures of water, born of oceans, shaped by tides. To walk across Utopia Planitia, even in imagination, is to confront a mirror. Here is what a world looks like when the oceans are gone. Zhurong's wheels traced the edges of that truth. Its radar touched the bones of that memory. And as we follow its path deeper into the plain, we prepare to plunge still further beneath the surface, to hear what the echoes beneath Mars's soil can tell us, not only about the planet's past, but about the possibility of life that might once have swum in its vanished seas. Beneath the rust-red dust, beyond the reach of any human hand, lies a record carved into stone. The rover Zhurong did not merely see the Martian world, it listened to it. Its most profound tool was not a camera nor a drill, but a set of ears pressed against the crust, ground-penetrating radar, sending pulses downward, waiting for the echoes to return. Every signal that came back was like a ghostly reflection, the planet answering in whispers, and in those whispers, a pattern emerged that hinted at seas and shores. Radar is, in essence, a way of asking the ground to reveal its secrets. On Earth, it is used to find buried rivers, hidden faults, even lost cities beneath deserts. But on Mars, it became an oracle. Zhurong carried 2 radar systems, one probing shallow depths, another reaching far deeper, slicing through layers up to 100 feet down. Each pulse dove into the soil and stone, bouncing off boundaries where one material met another, dust against sand, sand against rock, rock against ice. From those faint variations, scientists stitched together an image not of the surface, but of the world below it. What Zhurong revealed was astonishing. At depths of around 33 feet, it discovered continuous sheets of material tilted gently downward at about 15 degrees, stretching across vast distances. These were not chaotic deposits scattered randomly. They were ordered systematic, as though waves had once lapped against a shore, leaving grains stacked in patient sequence. On Earth, geologists call this progradation, the steady march of a shoreline as water advances, pushing sediment into angled wedges. The Martian layers mirrored this, like an ancient beach frozen in place. The image is haunting to imagine. Stand on that plain billions of years ago, and you might have seen water stretching to the horizon. Waves rolled forward, carrying sand that fell grain by grain in tilted layers. Season by season, year by year, the shore shifted, advancing into the basin. Over time, the accumulation grew thick, in some places more than 100 feet deep. To read those deposits today is to run a hand along the diary of an ocean. Yet the diary is incomplete, and interpretations diverge. Some scientists argue the radar slices could be explained by volcanic flows, overlapping in layers as lava cooled. Others see the fingerprints of wind dunes piled high, then cemented by minerals, Mars is a master of illusion, and radar, though powerful, cannot alone distinguish water's work from fire or air. Still, the geometry of those layers, the tilt, the consistency, the scale, leans heavily toward a shoreline. It is as though the planet itself is reluctant to confess, leaving just enough evidence to stir debate, but never enough to silence it. The echoes did not stop at 33 feet. At depths of more than 100 feet, Zhurong found even thicker stacks of material, hinting at repeated cycles of deposition. Some scientists interpret this as evidence of not one but multiple ancient seas, each filling and draining over eons. If true, Mars was not merely wet once, but episodically alive, with oceans, seas forming and retreating as climates shifted. The planet may have breathed water the way Earth breathes ice ages, rhythms of loss and return, leaving behind stratified memory. The possibility of hidden ice also lingers. Although Zhurong's radar showed no shallow ice within the top 16 feet, deeper layers could still conceal frozen reservoirs. Radar on orbiting spacecraft has found hints of ice beneath polar caps and even equatorial plains. If Utopia Planitia once held a sea, perhaps remnants still slumber beneath its floor, locked away in permafrost, waiting for warmth that may never come. The absence of shallow ice puzzled researchers, for many had expected it. Why was the upper soil dry? Perhaps past climate cycles melted and drained it away, or perhaps salts in the soil absorbed and transformed it. The question remains unanswered. For a moment, let us drift into speculation. Imagine the radar's echoes not only striking rock and sand, but something stranger, the preserved remnants of microbial mats, structures built by colonies of microorganisms. On Earth, such mats, known as stromatolites, have endured for billions of years, fossilized as living carpets of stone. If Mars once bore similar life, might radar have glimpsed their outlines? It is unlikely. The signals are too coarse, the distance too great, but the dream lingers. Beneath those tilted layers could be the archives of biology itself, hidden beneath the Martian desert. But even without such speculation, the science alone is staggering. To detect tilted strata at depths of tens of feet confirms that Mars is layered like a book. Each chapter is a climate, each page a change in wind, water, or lava. The radar gave scientists not only a vision of a lost sea, but a method to study Mars in ways no orbiting eye could. Cameras reveal surfaces, radar reveals time, and time is what Mars has most to teach us. As the rover continued its trek, the radar built a continuous record, a slice of Martian subsurface along its 1.2-mile journey. To compare it to Earth is to hold up a mirror. On our planet, prograded wedges are found in river deltas, lake margins, and coastal shelves. They are the signatures of water patiently building land. On Mars, the same geometry suggests that once under a thicker sky, tides rolled across Utopia Planitia, not a brief flood, but a sea with waves, currents, perhaps even storms that rattled against its shores. Yet debates grow sharper. Could dunes hardened by time mimic the look of beach deposits? Could lava flows stacked one atop another deceive us into thinking of water? The truth is that geology often plays tricks. Without samples in our hands, certainty is elusive. Some researchers insist the radar is too ambiguous to confirm an ocean, while others hail it as the most convincing evidence yet. The tension itself is a kind of poetry, Mars refusing to yield its secrets easily, demanding patience and humility. And still, the echoes persist. 30 feet, 100 feet, tilted and thick. They are there, and they must be explained. Whether water, lava, or wind, they mark events vast in scale, processes that shaped a world. To Zhurong, each echo was a heartbeat. To us, each is a reminder that Mars is not a dead desert, but a planet that once changed, moved, and flowed. Close your eyes and imagine lying down on that plain. Beneath you, the radar's pulses sink into the crust, brushing against hidden layers. In your mind, those layers unfold like waves rolling forward, whispering of seas that rose and fell long before humans dreamed of spaceflight. The silence around you is immense, the horizon endless, but below your resting body lies the memory of water. This is the gift of the rover's radar. Not merely data, but imagination. To sense the unseen, to turn echoes into landscapes. to transform silence into story. In the end, the rover was a listener, and what it heard beneath the Martian soil was a shoreline speaking across billions of years. And as the echoes fade, we turn to what they mean, not just for geology, but for the dream of oceans that lived and died on Mars, and the possibility that life once moved within them. A sea without waves. The phrase feels like contradiction, like thunder without sound or light without shadow. Yet on Mars, it may be the closest truth we possess. The radar signals that Zhurong returned did not capture the rush of water or the roar of surf. They captured the ghost of sediment, tilting patiently in the silence. The ocean, if it truly existed, is gone. What remains is not motion but memory, a sea held in stillness. To understand such a place, we must picture not the Mars we see today, but the Mars of billions of years ago. Imagine a world where the atmosphere was thick enough to hold warmth, where carbon dioxide pressed heavily upon the surface, trapping heat beneath a sky tinged copper and gold. Rain may have fallen then, running down channels that are now dry scars. Valleys carried rivers toward basins where water pooled and gathered until entire seas filled depressions like Utopia Planitia. By some estimates, this basin could have contained as much water as Earth's Arctic Ocean, covering millions of square miles. On Earth, when seas advance, they do so with rhythm tides, sculpt coasts, waves churn sand, storms pile deposits. On Mars, perhaps the rhythm was slower, muted by thinner gravity and weaker winds. The shoreline that Zhurong's radar uncovered does not show the violence of storm surges, but the patient advance of sediment. This hints that the Martian sea may have been calm, its waves small, its tides faint, a body of water subdued, almost asleep, a sea without waves. Yet even such a quiet ocean could have been profound. On Earth, life's earliest traces appear not in violent surf, but in calm shallows where sunlight penetrates, chemistry stirs and microbes thrive. Stromatolites, fossilized mats of microorganisms, grew in still waters, stacking layers of minerals as life built upon itself. If Mars held a similar sea, calm and long-lived, it may have been an incubator of possibilities. In its shallows, simple life could have tested the chemistry of survival. The thickness of the deposits Zhurong recorded strengthens this vision. Some layers extend over 100 feet deep, suggesting that sediment accumulated over millions of years. Such persistence defies the notion of a brief flood. This was not a flash of water unleashed by melting ice, nor a transient lake that evaporated in centuries. This was endurance. To build deposits so thick, the sea had to linger, to breathe with the planet's climate, to resist disappearance for vast stretches of time. The implication is clear: Mars once hosted stability. And yet, stability was not eternal. Something stole the ocean away. The leading theory is atmospheric loss. Billions of years ago, Mars may have possessed a magnetic field, shielding its air from the solar wind. When that field died, charged particles from the sun began stripping the atmosphere into space, molecule by molecule. With each passing eon, the blanket thinned. Without air, liquid water could not endure. It boiled away or froze, retreating into ice caps and underground vaults. The ocean of Utopia Planitia would have shrunk, retreated and vanished, leaving only sediment to tell the tale. The oddity of the Martian sea is its silence in the present. If such a body existed, why do we not see its remains as salt flats, dried basins or mineral-rich deltas as we do on Earth? In truth, fragments of such evidence exist. Orbital images reveal channels leading into Utopia Planitia, consistent with rivers feeding a basin. Certain minerals, clays and sulfates, hint at long-standing water, but time and dust are cruel. Mars's surface is ceaselessly eroded by wind. Over billions of years, the signs blur. What was once shoreline is now dune. What was once seabed is now plain. Zhurong's radar may have pierced through this erasure, glimpsing the hidden signature beneath. Still, skeptics remain. Could those tilted wedges not be lava flows, solidifying in layers as volcanoes erupted in distant past? Could they not be ancient dunes preserved by mineral cement? Now buried, the debate continues, sharp and unresolved. On Mars, almost every discovery comes paired with its counter-interpretation. For each whisper of water, another voice says fire. For every dream of oceans, another insists on wind. The planet resists confession. But science thrives on resistance. Each competing explanation drives new questions, sharper instruments, deeper missions. If Zhurong saw a shoreline, we must confirm it with samples, with microscopic study of grains. If it saw dunes or lava, we must learn why they mimic beaches so convincingly. Either way, the planet teaches us. Consider the speculative allure of what those deposits could contain. On Earth, coastal sediments are rich with fossils, chemical markers and organic remains. They are libraries of life. If Mars once harbored even the simplest cells, this is where they may have been preserved, buried quickly under layers of sand, shielded from radiation, locked in permafrost. To return such material to Earth would be to hold a page of cosmic history, perhaps the first proof that biology is not unique to our world. And yet, perhaps the Martian sea was sterile, a mirror of Earth's waters but without the spark of chemistry that births life. If so, it still matters. A dead sea tells us as much as a living one. It tells us how narrow the conditions for life truly are, how many worlds may drown in potential but never awaken. In that knowledge lies humility, the awareness that our own oceans are rare, fragile, precious. There is also the haunting possibility that life began there, only to die. Microbes could have thrived for millions of years, only to vanish when the atmosphere faded, when the sea dried. If that is true, then Mars is not only a planet of potential, but a graveyard of beginnings. The silence we hear today may not be emptiness, but extinction. The very phrase "a sea without waves" becomes metaphor. It is a reminder of time's cruelty, that even oceans can vanish, that even worlds can fall silent, and it is also a mirror of our own anxieties. For on Earth, seas rise and fall, climates shift, and the fragility of oceans becomes more visible each year. Mars whispers not only of its past, but of our future. So we return to Utopia Planitia, to the tilted layers buried 30 feet down, to the 100-foot stacks of sediment sealed in dust. Whether they are waves frozen in time or illusions of geology, they force us to imagine a world that was once more than desert. A world where seas stretched wide, calm and enduring, beneath skies thicker than today. A world where silence came only later, when the last drop vanished, leaving only memory. The rover's radar does not give us sound, but if it did, perhaps we would hear it still. The faint lap of water against a shore, frozen forever in stone. A sea without waves, but not without meaning. And as we contemplate that meaning, we drift into the next mystery. What such a sea could have offered to life, and whether Mars long ago ever truly lived. Life in a lost ocean. The phrase glows like a paradox, shimmering with both promise and grief. For Mars, the possibility of life is always a balancing act between what might have been and what may never be proven. The shoreline Zhurong's radar uncovered hints at water that endured for millions of years, and where water endures, life often follows. That is the rule written into Earth's history, but does the same rule apply to Mars? Let us step backward in imagination, billions of years into the past. Mars is warmer, wrapped in a thicker atmosphere, its skies hazy with carbon dioxide. Rivers cut valleys that we now see only as scars, their channels flowing toward basins like Utopia Planitia. There, water pooled, not briefly but for epochs. In its shallows, sunlight penetrated easily, minerals leached from surrounding rock fed the waters with nutrients. Volcanic activity nearby may have supplied heat and chemistry. It was in many respects a stage set for biology. On Earth, such conditions were not only sufficient, they were decisive. Our earliest known fossils, stromatolites, come from shallow seas more than 3 billion years old. These layered structures were built by colonies of microbes, capturing sunlight, exhaling oxygen, weaving minerals into living stone. If life arose on Earth in such waters, then Mars's ancient seas present an echo, a parallel possibility. Microbes may have clung to mineral grains, built mats on rocky shores, or drifted invisibly in the water itself. And yet, no fossils greet us in Martian stone. No clear biosignatures call across space. We are left with maybes, with echoes. The sediment layers Zhurong uncovered could in theory preserve organic remains, buried quickly under sand, shielded from radiation. Such material might survive even now, locked in permafrost. If a future mission retrieves samples from those deposits, Microscopes on Earth could search for isotopic ratios or microscopic textures that speak of metabolism. The potential is tantalizing proof that life is not unique to Earth. But perhaps the silence is itself the answer. Mars may have held oceans and rivers, but chemistry alone may not have been enough. Life requires not just water, but stability, cycles, and energy flows. On Earth, our planet's magnetic field shielded us from radiation, plate tectonics recycled nutrients, and the moon's gravity stirred our tides. Mars lacked these gifts. Its smaller mass let heat escape quickly, stilling tectonic churn. Its dynamo died, stripping away its magnetic shield. Perhaps oceans existed, but they were sterile mirrors reflecting the potential of life without ever sparking it. Speculation takes us further still. Some scientists wonder if life did arise, only to perish when the atmosphere faded. Imagine microbes thriving for hundreds of millions of years, only to vanish as waters boiled away, seas shrank, and radiation scoured the surface. In this vision, Mars is a graveyard of beginnings, a world where life almost succeeded. If true, then Martian sediments may not hold the presence of life, but its absence, organic molecules fractured, fossilized cells erased, isotopes scattered beyond recognition. Yet, amid the silence, hints remain. Curiosity rover once detected traces of methane in Mars's atmosphere, a gas on Earth often linked to biology. Perseverance rover, wandering in Jezero crater, found organics in rocks that once sat in a lake bed. These findings are not proof, but they are whispers. Combined with Zhurong's shoreline evidence, they sketch a picture of a planet that at minimum flirted with the conditions we associate with life. To imagine Martian life is to step into strangeness. If microbes existed, they may have been unlike anything on Earth. Perhaps they relied on perchlorates, salts abundant in Martian soil, as energy. Perhaps they thrived on iron chemistry, feeding on red dust. Without sunlight during global dust storms, maybe they slept, metabolizing slowly in darkness, waiting for skies to clear. Some researchers even speculate about shadow biospheres, life so different from Earth's that we would not recognize it. Life based not on DNA, but on some alternate coding, some alien script of molecules. If so, we might have walked past its fossils without knowing. The debates surrounding Martian habitability are not only scientific, but philosophical. If life existed and perished, what does that say about our own fragility? If Mars never knew life despite oceans, what does that say about Earth's rarity? Each answer humbles us. One reminds us that life can be extinguished, the other that it is precious beyond measure. In both cases, the silence of Mars is a mirror, showing us both our vulnerability and our fortune. For now, we live in the tension of uncertainty. The radar reveals layers suggestive of a sea, but not the chemistry within. The rover is silent, unable to dig deeper or bring samples back, and so the question remains suspended. Did Mars live? Did oceans cradle biology? Or were they only empty theatres, vast and waiting but uninhabited? The truth is locked beneath dust and stone, waiting for the hands of future explorers. Still, the imagery compels us. Stand on the shore of that vanished sea in imagination, the water calm, the air thin but breathable enough for the dream. The horizon glimmers with light reflected from waves. In the shallows, perhaps mats of microbes cling to rock, faintly altering the chemistry of water. Perhaps bubbles rise, invisible but significant, as metabolism whispers. In this vision, Mars is not barren but breathing, not silent but alive. The tragedy is that the vision may have ended long before we arrived. There is one more possibility, the most speculative and haunting of all. What if life began on Mars before Earth? Some researchers suggest that early Mars may have been more hospitable than early Earth. If microbes evolved there first, they could have been carried here by meteorites, fragments blasted from Mars by impacts, drifting across space, seeding Earth's young oceans. If true, then we are Martians, our ancestry tied not to Earth's oceans, but to Utopia Planitia's lost sea. The idea remains unproven, but it hangs in imagination, daring us to rethink our identity. Whether Mars birthed life, harbored it briefly, or remained forever sterile, one truth persists. The ocean it may once have held shapes how we see ourselves, for we are beings of water, and to find it elsewhere is to feel kinship. Zhurong's radar did not just detect sediment, it detected possibility. It asked the question, what does it mean for life to be rare or common, fragile or resilient? And so, the story moves forward. From the calm ocean that may once have lived, we turn now to the storms and stillness that define Mars today. The climate that shaped its silence, the winds that bury its history, and the skies that rage without rain. Zhurong, during its year of activity on the Martian plain, became an intimate witness to this duality. Its cameras gazed across horizons blurred by haze, capturing skies that dimmed the sun into a pale disk. Its instruments tasted the atmosphere, a whisper-thin blanket of carbon dioxide barely 1% as dense as Earth's air. For a rover depending on sunlight to live, the sky itself was both friend and enemy. On clear days, its panels drank enough light to drive its wheels and power its instruments. But when dust thickened, power drained and survival became uncertain. Mars is a world of storms and stillness, a paradox written in dust. Its skies seem calm when seen from afar, a faint red glow beneath the black ocean of space. But closer, through the eyes of orbiters and rovers, we witness a planet where winds can rise without warning, lifting fine grains into storms that swell until they engulf entire hemispheres. And yet, when the dust settles, the silence returns, deeper, sharper, more absolute than any silence Earth has ever known. The storms of Mars are not storms as we know them. On Earth, a storm is a clash of moisture and temperature, thunder and rain. On Mars, there is no rain, no lightning to strike the horizon. Instead, there is only wind and dust, particles so fine they behave almost like smoke, suspended for weeks, tinting the entire sky. Sometimes these storms begin as small whirlwinds, dust devils, spiraling across plains. Sometimes they grow, merging, until they form walls of dust, hundreds of miles across. In the most extreme cases, the storms envelop the planet itself, turning the global atmosphere into a dim orange twilight. In January 2022, Tianwen-1's orbiter looked down upon one such storm, vast enough to stretch thousands of miles. It rolled across the northern hemisphere, swallowing Utopia Planitia. To Zhurong, stationed upon the ground, this meant dim skies and fading energy. The rover was instructed to pause operations, conserve power, and wait for clarity. Imagine being there, a landscape once sharp, now blurred into rust-colored fog, the sun a ghost overhead, the horizon gone. The silence deepened, broken only by the faint hiss of dust against metal. Still, the data gathered before its sleep speaks volumes about Mars's climate. Temperatures near the surface swung violently, mild in the daytime sun, plummeting at night to -100 degrees Celsius or lower. Such extremes would freeze steel, crack rock, and demand survival strategies from any hypothetical organism. The air was thin, unable to buffer heat. Pressure barely rose above 6 millibars, just at the threshold where liquid water could exist fleetingly before boiling or freezing. And then, as storms always do, it passed. The winds dropped, particles settled, and the air cleared. Yet the aftermath lingered. Dust coated Zhurong's panels, forming a film that would not blow away. Each new storm added more, dimming the rover's lifeblood. Unlike NASA's Spirit and Opportunity, which sometimes benefited from cleaning events when gusts scoured their panels, Zhurong found no such fortune. Dust was patient, and in patience, it triumphed. By May 2022, the rover fell silent, its circuits too starved to wake. Mars is a world of storms and stillness, a paradox written in dust. Its skies seem calm when seen from afar, a faint red glow beneath the black ocean of space. But closer, through the eyes of orbiters and rovers, we witness a planet where winds can rise without warning, lifting fine grains into storms that swell until they engulf entire hemispheres. And yet, when the dust settles, the silence returns, deeper, sharper, more absolute than any silence Earth has ever known. Zhurong, during its year of activity on the Martian plain, became an intimate witness to this duality. Its cameras gazed across horizons blurred by haze, capturing skies that dimmed the sun into a pale disk. Its instruments tasted the atmosphere, a whisper-thin blanket of carbon dioxide barely 1% as dense as Earth's air. For a rover depending on sunlight to live, the sky itself was both friend and enemy. On clear days, its panels drank enough light to drive its wheels and power its instruments. But when dust thickened, Power drained and survival became uncertain. The storms of Mars are not storms as we know them. On Earth, a storm is a clash of moisture and temperature, thunder and rain. On Mars, there is no rain, no lightning to strike the horizon. Instead, there is only wind and dust, particles so fine they behave almost like smoke, suspended for weeks, tinting the entire sky. Sometimes these storms begin as small whirlwinds, dust devils, spiraling across plains. Sometimes they grow, merging, until they form walls of dust, hundreds of miles across. In the most extreme cases, the storms envelop the planet itself, turning the global atmosphere into a dim orange twilight. In January 2022, Tianwen-1's orbiter looked down upon one such storm, vast enough to stretch thousands of miles. It rolled across the northern hemisphere, swallowing Utopia Planitia. To Zhurong, stationed upon the ground, this meant dim skies and fading energy. The rover was instructed to pause operations, conserve power, and wait for clarity. Imagine being there, a landscape once sharp now blurred into rust-colored fog, the sun a ghost overhead, the horizon gone. The silence deepened, broken only by the faint hiss of dust against metal. And then, as storms always do, it passed. The winds dropped, particles settled, and the air cleared. Yet the aftermath lingered. Dust coated Zhurong's panels, forming a film that would not blow away. Each new storm added more, dimming the rover's lifeblood. Unlike NASA's Spirit and Opportunity, which sometimes benefited from cleaning events when gusts scoured their panels, Zhurong found no such fortune. Dust was patient, and in patience, it triumphed. By May 2022, the rover fell silent, its circuits too starved to wake. Still, the data gathered before its sleep speaks volumes about Mars's climate. Temperatures near the surface swung violently, mild in the daytime sun, plummeting at night to -100 degrees Celsius or lower. Such extremes would freeze steel, crack rock, and demand survival strategies from any hypothetical organism. The air was thin, unable to buffer heat. Pressure barely rose above 6 millibars, just at the threshold where liquid water could exist fleetingly before boiling or freezing. The storms, the cold, the thin air, all tell a story of a planet that once was warm enough for seas, but lost its shield against space. Billions of years ago, Mars likely had a magnetic field. With it, the atmosphere could resist the stripping force of solar wind. Without it, molecules fled into the void. Over ages, the blanket thinned, the seas vanished, and storms replaced rain. What remains is a climate of extremes, fragile yet enduring. Odd phenomena add to the mystery. Scientists have long debated whether faint traces of methane measured in Mars's atmosphere might point to life or geology. Methane is unstable in air, destroyed quickly by sunlight. If it exists, it must be replenished. Could underground microbes produce it, exhaling gas into the sky? Or could geologic reactions in rock release it without biology? The data is inconsistent, sometimes showing spikes, sometimes silence. It is one of the great open questions of Martian climate. Other mysteries linger in the dust itself. The fine grains are rich in perchlorates, salts that on Earth are toxic but could serve as chemical fuel for extremophiles. They also draw water from the air, forming briny films that might briefly wet the soil. Could microscopic organisms survive in such hostile chemistry, sleeping during cold nights, stirring only when brines form? No proof exists, but the possibility hovers like the haze after a storm. Standing in imagination beside Zhurong, you would feel the strangeness of Martian weather. The wind would tug faintly at your suit, too thin to push hard, but carrying dust that coats everything it touches. The air would feel sharp, metallic, almost absent, as though you breathe through emptiness. The temperature would drop swiftly as the sun sets, the warmth fleeing into space unopposed. And above, the sky would glow pink-orange by day, darkening into a starfield unblurred by clouds. No sound of rain, no crash of thunder, only wind whispering through dust. Mars's storms are fragile things, yet they carry immense symbolic weight. They are reminders of loss. They show us a world that once had clouds and perhaps rainfall, now reduced to dust spirals. They remind us of Earth's luck, a planet thick with water storms instead of dust. And they remind us of fragility. Remove a magnetic field, thin an atmosphere, and seas collapse into deserts. Mars is what happens when a planet forgets how to keep its sky. But within the stillness that follows storms, there is also beauty. The dust paints sunsets in deeper hues than any on Earth, turning the horizon into a gradient of violet and orange. Shadows stretch long across plains, sharp and cold. Stars pierce the night with startling clarity. In that stillness, one feels both awe and unease, awe at the vastness, unease at the silence. It was in such silence that Zhurong now rests, its last words sent before storms consumed its light. Perhaps one day, another rover will roll past, brushing dust from its panels, reawakening its voice. Or perhaps it will remain a monument, a sentinel half buried, watching storms rise and fade through centuries. Either way, it stands as witness to a climate caught between fury and calm, storms and stillness. And as we leave the winds behind, our journey turns toward the silence itself, the fading of signals, the final breath of machines, and the melancholy of explorers who vanish into dust. Signals fading in the dust, that is how Mars speaks to us. Not in words, not in songs, but in pulses of radio light that travel millions of kilometers before whispering into the ears of antennas on Earth. For a year, those signals came faithfully from the rover Zhurong. Each transmission carried images, radar echoes, weather readings, fragments of a world slowly unveiling itself. And then, like the last ember of a fire, the signals dimmed, faltered, and fell silent. The silence of a machine is unlike any other silence. It is the pause of something that once spoke, but now no longer can. Engineers at Mission Control sent commands into the void, waiting with tense patience for a reply. The minutes stretched, 7, 8, 10, as the signals traversed the gulf between planets. Sometimes a faint acknowledgement came, a flicker of life, sometimes nothing. In May 2022, the last words arrived. After that, only the emptiness of Utopia Planitia remained. Why did the rover fall silent? Dust is the most likely culprit. Mars is a world obsessed with dust. Fine particles that settle on every surface, clinging stubbornly to solar panels. Over time, Zhurong's panels darkened, absorbing less sunlight. Without energy, heaters failed, and the Martian night crept in with its terrible cold. Circuits strained, batteries weakened. It is possible that beneath its still exterior, the rover sleeps, waiting for a gust of wind to clear its panels. But the winds of Utopia Planitia are rarely so generous. More likely, Zhurong has spoken its last. There is melancholy in this ending, but also nobility. To cross another planet for more than a mile, to return data that reshape debates about oceans, to endure dust storms and freezing nights. This is triumph. Machines, like people, have lifespans. They leave behind not their bodies, but their contributions. Zhurong's legacy is written not only in the tracks across Martian soil, but in the layers of sediment it revealed to the world. Yet the silence stirs deeper feelings. We are creatures who dream of companionship, even with our machines. When Spirit and Opportunity rovers fell silent, people mourned as though losing friends. When Voyager spacecraft sent their last whispers from the edge of the solar system, humanity listened with reverence. These machines are extensions of us, our eyes, our ears, our questions cast into the cosmos. When their voices fade, it feels as though a part of us is stranded in silence, alone beneath alien skies. There is also the eerie thought that Zhurong now stands as a statue, frozen mid-journey. Imagine walking across Utopia Planitia, centuries from now, and finding it, a small rover half buried in dust, its panels dull, its mast pointed forever toward the horizon. Around it, the landscape unchanged. No wind strong enough to erase its tracks, no rain to wash them away. On Earth, ruins crumble, jungles reclaim stone, oceans erode coasts. On Mars, time is slower. The rover may endure for millions of years, a monument to human persistence. Speculation extends further. What if Zhurong is not entirely gone? What if, deep in its circuits, some charge remains, waiting for a rare gust of wind to clear its panels? The red planet has surprised us before. NASA's Opportunity rover, thought lost to a dust storm in 2007, revived after weeks of silence, awakened by cleaner skies. Perhaps Zhurong too could stir again, sending a sudden ping across space, a voice returning from presumed death. Engineers continue to listen, just in case. But for now, silence reigns. And silence on Mars is not gentle. It is absolute, vast, oppressive. On Earth, even in the quietest desert, you hear the rustle of wind, the buzz of insects, the beating of your heart. On Mars, the air is too thin for sound to carry far. Step outside, and the silence presses like weight upon the body. To imagine Zhurong within that silence is to imagine loneliness incarnate. Yet even silence teaches. The rover's end is a reminder of how fragile exploration is, how easily dust can undo years of engineering. It is also a lesson in humility. We do not control other worlds, we only visit them. Our machines are guests in alien environments, subject to conditions they cannot master. Dust is not an obstacle to Mars, it is Mars. To fight it is to fight the planet itself. And still, the silence is not meaningless. The data Zhurong sent before sleeping continues to be analysed. Each radar echo, each mineral scan, each weather reading holds insights that will take years to unfold. In this way, the rover still speaks. Its voice is now in numbers, in charts, in discoveries whispered at conferences and printed in journals. Silence on Mars becomes knowledge on Earth. There is a speculative thought that lingers in the imagination. What if, in some distant future, life, human or otherwise, finds Zhurong and reawakens it? What would the rover make of the time past, the centuries of silence? Would it resume its tasks as though no moment had gone by? Would it remember the last commands it received, a machine consciousness spanning epochs in a single pause? Such thoughts belong to science fiction, yet they reveal the emotional bond we hold with these emissaries. We cannot help but humanize them. More soberly, Zhurong's silence echoes into geopolitics. Its success placed China firmly among the powers capable of reaching Mars. Its silence reminds us of the limits all nations face. Machines break, dust wins, plans must adapt. As China prepares its next steps, atmospheric models, sample return missions, Zhurong stands as both proof of possibility and a warning of challenge. Imagine for a moment that you are standing beside the rover now. The air is thin and sharp, the horizon endless, the sky a muted orange. The rover is still, its panels coated, its wheels half buried. You place a hand upon its hull, cold metal warmed faintly by the sun. No signal passes through its circuits, and yet in that moment you feel the weight of what it accomplished, the story it carried across space. In silence it speaks louder than words. The end of Zhurong's voice is not the end of its journey. It is a transition from a living machine to a monument, from signals to memory. It reminds us that exploration is not a straight path, but a series of echoes fading and re-emerging, each mission paving the way for the next. The rover may sleep forever, but the questions it raised remain awake, alive, urgent. And those questions turn us forward. What comes next for Mars exploration? What bold steps will follow silence, and how humanity, through China, NASA and others, will carry the story onward. The silence of Zhurong does not end the story. It opens the path for what comes next. For even as one rover rests forever in Martian dust, plans unfold on Earth for the next chapter of China's exploration. Tianwen-1 was never meant to stand alone. It was the first question to heaven, and every question demands an answer. That answer lies in missions yet to fly, atmospheric models, new landers, and most ambitious of all, the return of Martian soil to Earth. China's vision begins with Go Mars, a high-resolution atmospheric circulation model designed to capture the climate of Mars in exquisite detail. While orbiters like Tianwen-1 measure dust storms and temperatures directly, Go Mars integrates that data into a living simulation, predicting winds, pressure changes, and storm formation across the entire planet. Why does this matter? Because to land future spacecraft safely, especially ones meant to launch back into space, we must predict Mars's weather as confidently as we predict our own. On a world where storms can swallow continents, foresight is survival. But beyond models lies hardware. Engineers are already sketching blueprints for Tianwen-3, China's first attempt at a sample return mission. If successful, it would make China only the second nation in history, after the United States with the Moon, to retrieve material from another planetary body. The timeline is breathtakingly ambitious. Launch in 2028, land on Mars in 2029, collect samples, and return them to Earth by July 2031. That is less than a decade from now, a heartbeat in cosmic terms. The mission is designed with bold precision. A lander will descend to the surface, carrying a small vehicle capable of scooping soil and coring rocks. These samples, sealed in containers, will then be loaded into an ascent vehicle, a rocket that must launch from the Martian surface, fight gravity and rendezvous with an orbiter waiting above. The orbiter, in turn, will carry the capsule back across interplanetary space, releasing it into Earth's atmosphere for recovery. Each step is a symphony of engineering, where failure at any note means the music ends. And what will those samples contain? Just ounces, perhaps half a kilogram in total. Enough to fill a jar, less than the weight of a paperback book. Yet within those grains may lie answers to questions older than humanity. Was Mars once alive? Did oceans cradle biology? Did the planet evolve in parallel with Earth before diverging into silence? To scientists, such ounces outweigh gold. Landing sites are already under discussion. 19 candidates have been studied, spread between 17 and 30 degrees north latitude. Among them, Utopia Planitia is favoured, for it promises both scientific richness and engineering safety. A site where radar already hinted at shorelines could yield sediments holding chemical secrets. Imagine, then, a spacecraft scooping soil from the same plain where Zhurong rests, carrying away grains that bear the memory of vanished seas. But the plan is not only about science, it is about competition. NASA and the European Space Agency are developing their own Mars sample return mission, aiming for a similar timeline in the early 2030s. To be first is to claim prestige, to ignite a modern echo of the Sputnik moment. NASA's administrator, Bill Nelson, has already voiced concern that China could return samples before the West, reshaping the balance of space leadership. In this way, every ounce of Martian soil carries not only history, but politics. Speculation adds further drama. What if the samples reveal traces of life, fossilized microbes, organic molecules, or isotopic patterns that cannot be explained by chemistry alone? Such a discovery would not belong to one nation, it would belong to humanity. And yet, in the geopolitics of Earth, would it be seen that way? Or would the first to return samples claim the first proof of life beyond Earth as their triumph? Mars, in this sense, is not only a world of science, but a stage for human rivalry. Still, beneath the politics, the deeper meaning glows. Returning Martian soil is not about flags or rivalries. It is about touching another world in the most intimate way. To hold in one's hand a grain of sand from Utopia Planitia is to collapse the gulf between planets. It is to bring a piece of the cosmos into our laboratories, to study it under microscopes, to taste its chemistry with instruments too delicate to fly. It is to listen more closely to the whispers that Zhurong first heard. Consider the challenge of such a mission. Launching from Earth is difficult enough, with vast rockets and global infrastructure. Launching from Mars requires all that, but automated on a planet with no support. The ascent vehicle must ignite flawlessly. The rendezvous with the orbiter must be timed with astronomical precision, and the return capsule must survive a plunge through Earth's atmosphere at interplanetary speed, glowing like a star before opening its parachute. The engineering risk is staggering, and yet the prize is worth it. Speculative voices add even stranger possibilities. What if the samples contain dormant microbes, still alive after billions of years, frozen in Martian permafrost? Could they awaken on Earth? The risk is small, sterilization protocols will be extreme, but the thought itself stirs unease. Others dream more brightly. What if we learn from Martian life new forms of biochemistry, new medicines, even new perspectives on evolution? Samples may carry not danger, but wisdom. The pursuit of samples is at its heart the pursuit of intimacy with Mars. For decades we have looked from afar, photographed from orbit, drilled shallowly with rovers. But to bring material home is to bridge distance in a way nothing else can. It is to allow scientists to touch, to smell, to probe with every tool humanity has invented. It is to invite Mars into our laboratories, to let it teach us not as distant students, but as close companions. And yet, the mission will not be only science. It will be a rehearsal for something greater. To return samples requires ascent vehicles, rendezvous technology, and precision landings. These are the very skills required to one day return not with soil but with people. Tianwen-3 is not only about the past of Mars but about the future, about bases, habitats, and colonies. Each grain of soil may be a stepping stone toward footsteps. Picture it, the return capsule streaking through Earth's night sky in 2031, a fiery messenger bearing dust from another world. It lands in a desert, parachutes blooming, scientists rushing forward. They lift the capsule with gloved reverence, open it within sealed chambers, and pour out grains that last touched sunlight under a Martian sky billions of years ago. Those grains tell stories of oceans, climates, and perhaps life, and humanity listens, ears pressed to alien sand. The silence of Zhurong, then, is not an ending but a handoff, where one rover's voice fades, another mission's begins. China's steps on Mars are only just forming. What they found is astonishing, but what they seek next is greater still. And so we continue forward, from the soil itself to the broader stage, where not only science but rivalry defines Mars. For the Red Planet has become not only a world to study, but a prize to claim, and in that pursuit, the echoes of an old space race stir anew. Mars is not only a desert of stone and silence, it has become a frontier of rivalry, a mirror reflecting humanity's ambitions and anxieties. The new space race is not fought with soldiers or fleets, but with machines, data, and time. And unlike the Cold War race that once pointed rockets at the moon, this one stretches across 2 planets with Mars as the prize. The echoes of the past are clear. In 1957, the Soviet Union shocked the world with Sputnik, the first artificial satellite. In that moment, the balance of pride and power shifted. America responded with Apollo, planting human boots on the moon in less than a decade. Today, Mars has become the new Sputnik, the test of which nation can prove its mastery of space beyond Earth. Zhurong's landing was itself a Sputnik moment. China became only the second nation in history to operate a rover on Mars. The world noticed, and now the race has moved to the next milestone, the return of Martian soil. NASA and the European Space Agency have long planned their joint Mars sample return mission. Perseverance rover, already at work in Jezero crater, is collecting samples in sealed tubes. These caches wait like treasures, to be retrieved by future landers. The mission aims for the early 2030 sets, with a launch in 2028, a return capsule arriving around 2033. But China's Tianwen-3 threatens to beat this timeline. With a planned launch in 2028 and a return in 2031, China could bring Martian samples home years earlier. For scientists, the difference is small. For politics, it is enormous. NASA Administrator Bill Nelson has voiced concern openly. If China brings back samples first, he warns, it may trigger a shift in perception akin to Sputnik. The first Martian rocks returned to Earth would be a triumph claimed on the global stage. Headlines would proclaim it as a symbol of leadership, a proof of who is first among equals. The science would belong to all humanity, but the prestige, the story told in classrooms and history books, would belong to the nation that succeeded first. Yet beneath the rivalry lies cooperation. Science is porous. Discoveries cross borders faster than politics can contain them. If China returns samples, international teams will clamour for data, for publications, for collaboration. Similarly, if NASA and ESA succeed, Chinese scientists will study their results. Mars itself is indifferent to our flags. Its sediments do not care who lifts them, only that they are lifted. Still, nations are human, and humans crave victory. There is also the matter of bases. Mars is not only a site for rovers and return capsules, it is the dream of colonies. China has spoken of building permanent robotic stations, precursors to human outposts. NASA's Artemis program points toward the moon, but always with Mars in its sights. SpaceX, a private company, envisions fleets of ships ferrying settlers to the Red Planet. In such visions, rivalry grows sharper. To be the first to establish a base on Mars is to write a new chapter of history, one that will be read for centuries. And yet, the challenges remain colossal. To survive on Mars requires solving problems that dwarf even Apollo. Radiation pours down from the sun and cosmic background, unshielded by a magnetic field. Temperatures swing violently, from near freezing by day to lethal cold by night. Dust infiltrates everything, clogging machinery, poisoning air with perchlorates. To build a base is to construct a fortress against an entire planet. The rivalry, then, is not only between nations but between humanity and Mars itself. Speculation deepens the drama. Imagine that samples brought back in 2031 or 2033 reveal fossilized microbes, proof of a second genesis of life. The discovery would transform not only science but philosophy, religion and culture. And yet, who unveils that discovery first will shape the narrative. If China announces Martian life, it will be hailed as the dawn of a new age in Beijing. If NASA does, Washington will claim it as the next Apollo moment. For humanity, the discovery is universal. For nations, it is glory. Open questions swirl. Can cooperation temper rivalry? Might scientists from China, America, and Europe study Martian samples together, pooling expertise? Or will mistrust fracture the effort, with each nation guarding its grains of Martian soil like treasure? The answer is uncertain. Politics shapes even the most cosmic of quests. The International Space Station showed us cooperation is possible. The arms race of the Cold War showed us rivalry is inevitable. Mars once again will test which instinct dominates. And yet, for all the politics, the deeper truth persists. The race is not only against each other, but against time. Mars is not static. Dust storms alter its surface. Radiation degrades organic molecules. The sooner we return samples, the fresher the record. Waiting decades risks losing subtle evidence of past biology. In this sense, the space race is urgency not just for prestige, but for preservation. To delay is to let time erase clues. Standing back, the image is haunting. Two sets of spacecraft, one Chinese, one Western, preparing to leap toward the same world, to retrieve the same prize. Engineers on opposite sides of Earth sketching similar rockets, writing similar algorithms, chasing the same dream. It is rivalry, yes, but it is also a mirror. Humanity is divided by politics, yet united by curiosity. Mars, in its silence, draws both together, forcing us to confront the paradox. We compete, and yet we seek the same answers. Speculative voices imagine even stranger outcomes. What if both missions succeed, returning samples in 2031 and 2033? What if those samples contradict each other, one showing evidence of biology, the other showing none? Would we doubt the science, or would we accept that Mars, like Earth, is patchwork, alive in one place, barren in another? Or what if one mission fails, the capsule lost in re-entry, while the other succeeds? The consequences for prestige, funding, and global perception would be enormous. To walk through this future in imagination is to feel both wonder and unease. The wonder, humanity standing on the brink of its greatest discovery, the confirmation of life beyond Earth. The unease that such discovery may be filtered through rivalry, claimed as victory rather than shared as truth. Mars, once again, holds a mirror not only to its own past, but to ours. In the end, whether rivalry or cooperation prevails, the red planet remains the ultimate arbiter. Its sediments hold their secrets indifferent to politics. Its shorelines, if real, will not vanish because of flags. What matters is that we reach them, study them, listen to what they whisper. Rivalry may fuel the rockets, but curiosity fuels the spirit. And as the race intensifies, we move beyond missions to samples, toward dreams of permanence, not just visits to Mars, but habitation. The rivalry of nations gives way to the deeper question: what does it mean to live on another world? Dreams of colonies on Mars begin where science ends and imagination takes root. Already, the outlines are drawn, sketches in engineering labs, animations in documentaries, proposals in conference halls. But beneath the renderings lies a question both fragile and immense: can humanity ever truly live on Mars? The appeal is undeniable. A new frontier, a second home, a safeguard against catastrophe on Earth. To build a base on Mars is to write ourselves into the cosmos, to prove that our story is not bound to a single planet. It is also, in quieter ways, a continuation of the oldest human impulse to explore, to wander, to build where none have built before. Just as deserts became cities and oceans became highways, so too might Mars one day become a home. Yet the challenges are staggering. Mars offers none of the comforts that nurtured us on Earth. The air is unbreathable, thin and suffused with carbon dioxide. The temperature swings are brutal, plunging to -100 degrees Celsius at night. Radiation rains constantly from the sun and the cosmos, unchecked by a magnetic field. Dust chokes machinery, laced with perchlarates that are toxic to human physiology. To live on Mars is not to stroll in a red desert beneath an alien sky. It is to build fortresses against a hostile planet. Consider air. To breathe on Mars, we must create domes or tunnels sealed against the vacuum. Technologies like MOXIE, an experiment aboard NASA's Perseverance rover, have already shown that oxygen can be produced from carbon dioxide, splitting molecules into breathable gas. But scaling this to sustain entire colonies will require machinery vast and reliable, operating without fail in an environment where repair is perilous. Consider water. Some exists as ice buried beneath poles or locked in subsurface reservoirs. Extracting it means drilling, melting, purifying. Each liter is precious for drinking, for farming, for splitting into hydrogen fuel. Colonists will need recycling systems that capture every drop of sweat, every exhale of vapor, every trace of waste. On Earth, water flows freely. On Mars, it must be hoarded like treasure. And then there is food. To ship every meal from Earth is impossible. Colonies must grow crops in greenhouses, protected from radiation, nourished by Martian soil, stripped of its toxic salts. Perhaps hydroponics or aeroponics will feed settlers, roots dangling in nutrient mist. But farming requires light, warmth, and energy. Solar panels may dim under dust. Nuclear reactors may hum beneath domes. Each calorie eaten will be a triumph of engineering. The speculative visions grow stranger still. Some dream of terraforming, altering the planet itself to make it Earth-like, by thickening the atmosphere with greenhouse gases, by melting polar ice, by seeding the air with microbes. They imagine Mars warming, oceans refilling, skies deepening to blue. It is a vision of planetary resurrection, but calculations are sobering. Mars lacks sufficient carbon dioxide to thicken its air. Even with centuries of effort, full terraforming may be impossible. The dream of walking unprotected under a Martian sun may remain dream alone. And yet, colonization may not require transformation of the whole planet. It may require only pockets of habitability, domes, caverns, stations carved into basalt cliffs. These islands of life could thrive in seas of desolation, just as Antarctic research bases endure in Earth's coldest deserts. Colonies may begin as outposts, each housing a few dozen pioneers, growing slowly, linking together into networks. Over generations, they may expand into true settlements, towns beneath transparent roofs, cities woven into craters. But why go at all? Some answer survival. A second planet offers insurance against disasters on Earth, asteroid impact, nuclear war, climate collapse. If humanity spreads, it endures. Others answer curiosity, the same force that drove Polynesian sailors across oceans or astronauts onto the moon. Still others answer ambition, to test ourselves, to master new frontiers, to prove we can. There is also the possibility that Mars will teach us more than it shelters us. Living on another planet forces humility. Every breath will depend on technology. Every sip of water, every seedling, every watt of energy will be hard-earned. Such fragility may change us. Colonists may live more consciously, aware of resources, aware of dependence. Perhaps they will teach Earth by example, showing what it means to live within limits. Yet dangers haunt the dream. Radiation exposure could shorten lifespans, mutating DNA. Psychological isolation could erode minds. No forests, no oceans, no familiar skies. Children born on Mars might grow taller under weaker gravity, but frailer. Would they be able to return to Earth, or would their bones collapse under the weight of our gravity? Mars may shape not only technology, but biology itself. Colonists may in time become a different branch of humanity. Still, the dream persists. One can imagine standing within a transparent dome, watching dust storms sweep across plains beyond, while inside, green plants reach toward lamps. One can imagine children learning to walk in low gravity, bounding higher than Earth allows. One can imagine a Martian dawn, twin moons lingering in the sky, settlers watching as sunlight spills across red hills. These images are no longer science fiction alone, they are blueprints, debated and refined. Open questions remain. Will the first colonies be national, Chinese bases, American bases, or international, shared by many? Will private companies like SpaceX lead, or will governments hold the reins? Will Mars be divided by borders, or declared the common heritage of humanity? History warns us that frontiers often divide as much as they unite. The Antarctic Treaty showed cooperation is possible. Colonization of the New World showed rivalry and conquest. Which path Mars takes remains unwritten. There is, too, the haunting thought of discovery. What if colonies one day uncover undeniable fossils of Martian life, or even microbes still alive beneath the surface? How would humanity respond, living side by side with another biology? Would Mars remain a colony, or would it be recognized as a world with its own claim to existence? The ethics of colonization grow heavier with that possibility. And yet, perhaps the deepest truth is simpler. To build a colony on Mars is to build a mirror of ourselves. The way we approach it, with rivalry or cooperation, with respect or exploitation, will reflect our nature more than Mars's. The red planet is a canvas, and upon it we will paint our hopes, our flaws, our resilience. For now, the colonies remain dream. No human has set foot on Mars, no dome has yet risen, but the steps are being prepared. Sample return missions, cargo landers, atmospheric models, rockets tested on Earth. Each mission is a stone in a bridge. Whether it leads to a base or ends in silence, we cannot yet know. What we do know is this: Mars draws us onward. Its lost oceans call to ours. Its silence calls to our voices. Its challenges call to our courage. And as we dream of colonies, we find ourselves dreaming of something deeper. What it means to be human, not just on Earth, but across the stars. Beyond discoveries and rivalries, beyond rovers and rockets, there comes a moment of reflection. Mars is not only a world of dust and science, it is a mirror in which we glimpse ourselves. To look at the buried shorelines of Utopia Planitia, at the radar echoes of vanished seas, at the silence of machines stranded in storms, is to see not only Mars's past but Earth's present, and perhaps our future. For what Mars teaches us above all is fragility. Once it may have been alive with oceans, rivers, rain. Once it may have held skies thick enough to shelter water, climates stable enough to endure. Now it is barren, its seas are gone, its air thin, its rivers carved into scars. What was lost there could one day be lost here. Planets are not immortal, climates change, atmospheres vanish, oceans retreat. Mars is not only a neighbor in space but a warning in time. And yet, there is beauty in its silence. For in that silence, we hear the echo of possibility. The very fact that Mars may once have mirrored Earth reminds us that worlds can bloom, and the very fact that it lost its oceans reminds us of the razor's edge upon which life balances. To see both is to stand in awe at how rare our own seas are, and at how easily they might slip away. When we study Mars, we also study ourselves. The debates over ancient oceans, the search for life, the dreams of colonies, these are not just about the red planet. They are about our need to know whether we are alone, about our hope to endure, about our longing to belong to the cosmos. Each rover that lands there is an extension of us, a fragment of human curiosity rolling across alien soil. Each echo of radar is a question we have asked ourselves for millennia. Are we unique, or are we part of something greater? The answers remain uncertain. Perhaps life never existed on Mars, and we are indeed rare beyond measure. Perhaps life began and perished, and we are the survivors of a fragile lineage. Perhaps fossils wait beneath Utopia Planitia, ready to show us that biology is not Earth's alone. Each possibility reshapes how we see ourselves, each equally profound. Speculation stretches further still. Some imagine that life began there, carried to Earth on meteorites, making us, in some sense, Martians. Others imagine Mars as humanity's next home, where children yet unborn will bound in low gravity, their voices echoing beneath domes. Others still imagine Mars as a world forever silent, its only inhabitants the machines we leave behind, guardians of memory rather than seeds of the future. Mars accommodates all these dreams. It is vast enough to hold them all. And so, as we conclude our journey, we return to the imagery that began it. Beneath the rust-red dust, there may lie a shoreline, tilted layers of sand that once felt the caress of waves. Those waves are gone, but their imprint endures, like fossils of motion. Above them, the rover rests, silent now, its mission complete, its story passed on. Beyond, the sky glows faintly with dust, storms wandering without rain. Around the planet, orbiters continue their watch, listening for signals, gathering data, building the bridge to what comes next. For humanity, Mars is not just science. It is wonder, melancholy, ambition. It is the reminder that planets change, that seas vanish, that silence follows song. And it is also the invitation to dream of life that may have been, of colonies that may yet be, of connections that span not just nations but worlds. And so we slow our pace, letting the rhythm of words soften, the imagery quieten. The winds of Mars fade in imagination. The dust settles, the silence deepens. We find ourselves no longer on a red plain, but back within ourselves, breathing gently, our own pulse steady. Mars lingers in the mind as a companion, a reminder of fragility and possibility alike. As you drift now into rest, hold this thought: the universe is vast, yet within it, worlds whisper. They whisper of oceans lost, of futures imagined, of questions eternal. Mars is one such whisper, carrying across space, faint but insistent. It asks us who we are, where we come from, where we are going. In listening, we remember that to be human is to wonder is to dream is to belong. And in that belonging, there is peace. Let it carry you gently now into the stillness beyond thought, into the quiet oceans of sleep. The red planet remains, waiting, watching, whispering, and tomorrow the questions will still be there, waiting for us to listen again.